This lesson is on solving rational equations. Rational equations are equations with rational expressions in them. For example, the following. So first off, you always want to determine the domain. The domain tells you what possible x values are allowed to be input into the variable in our equation. So later, when you find your answers, you can check against the domain to see, hey, maybe some of these answers don't actually work. Remember, with fractions, you never want to have a 0 in your denominator. So if your denominator has a variable in it, it could potentially be 0 if the correct number was in there. So here you have an x in the denominator, so 3x cannot equal 0, therefore x cannot equal 0. In the second denominator, x also cannot equal 0, so your domain cannot be 0 for x. So if your answer ends up being 0, you cannot include that answer in your solution set. Very important. Second, as before, we have an equation, so we're allowed to multiply every single term by the same number, and that number or expression should actually be the lowest common denominator. So some people like to get everything in the common denominator first. They find that easier to do. So let's do that. What is the lowest common denominator here? Well, it's 3x. So this one is done. There's nothing we need to multiply by. But this one we need a 3, so we multiply numerator and denominator by 3 to make the denominator the same. And this one we also need to multiply by x to make the denominator the same. So we now have 4 over 3x minus 9 over 3x equals 10x over 3x. Now, we can go ahead and multiply everything by the lowest common denominator, which is 3x, and we're allowed to do that because of the equation. So notice you can only do this for equations. Do not attempt doing this when you do not have an equal sign because it will not be correct. Okay, so multiply by 3x, divide by 3x, that's gone. Multiply by 3x, divide by 3x. Similarly, you're left with 4 minus 9 equals 10x. Great! Now, we can solve the equation, check our solutions, and state our final answer. So that gives us negative 5 equals 10x. Divide both sides by 10, and you get x equals negative 1/2. Your answer is not something that impacts our possibilities in terms of the domain, so it's fine, and here is our final answer. So the solution set includes negative 1/2. All right, here's another example. So we want to multiply everything by the lowest common denominator, or you can first get it into the common denominator and then multiply by it to eliminate it. So here we need the other factor, 5x minus 12. And here we also need the x. So whatever you do to the denominator, you have to do to the numerator. So this is similar to when you're adding or subtracting fractions, but the difference here is that we have an equal sign. Now that equal sign makes things a little different than if it was just a plus sign, obviously, but the main key point here is if you had a plus sign, you'd have to keep the denominator. But because you have an equal sign, you can essentially multiply both sides by the denominator, and then it is eliminated. Again, this can only be done if there is an equal sign there. So that's the denominator is gone. So we're left with 2 times 5x minus 12 equals x squared. So now we need to solve this. So we've got 10x minus 24 equals x squared. But since we have a square in our equation, we need to get everything onto one side equal to 0 and factor. So let's get everything to the right side because that's where x squared is positive, and then we don't have to factor out a negative. So we'll have 0 equals x squared minus 10x plus 24. Now can we factor that? So is there a product of 24 and a sum of negative 10? 6 and 4, 6 times 4, so the signs have to be the same to give us a positive, and they need to be negative to give us a sum of a negative. So there we go. And so from there, we have either x minus 6 equals 0 or x minus 4 equals 0, leaving us with x equals 6 or 4. But we need to test both of those to double check, are they in our domain? Well, the domain is x cannot be 0 and 5x minus 12 cannot be 0, which means that 5x cannot equal 12, which means that x cannot equal 12 over 5. Well, 6 and 4 do not make either of those denominators 0, so they are both in our solution. So our solution set is made up of 6 and 4. Here's another example. Now remember, when you find your LCD, you always want to factor first, if possible. The other cases we didn't need to factor, but in this case I think we do. So let's rewrite it, and remember, when you rewrite it, make sure there's lots of space. So we factored the 2 in the first one, a 4 in the second one, and this one is already done. Again, remember to put in those brackets if there are more than one term in a numerator or denominator of a fraction. So what is the common denominator? Well, we need to have this 4 and this x plus 1. Okay, so we need to multiply this one by 2, this one is complete, and this one by 4. Now, since all the denominators are the same and we have an equation, then we can multiply everything by the denominator and we're left with just the numerator. Please remember that you cannot do this if you don't have an equation. I cannot stress that enough. Okay, let's keep going. So that's 2x equals negative 2x plus 8x minus 12. We'll collect our like terms, so 2x plus 2x minus 8x equals 12. There's no squares, so we just get our x's on one side and the numbers on the other side. So we've got 4 minus 8, which is negative 4x equals 12. And when we divide by negative 4, we get negative 3. Now, we also want to know our domain. So our domain does not allow us to have x plus 1 equals 0, which means x cannot be negative 1. So our solution is fine. So our final solution is just to negative 3. Here's a bit of a longer one. So again, factor first, especially if you have bigger denominators like this. So instead of x minus 6x plus 5, we can write x, so product of 5 is just 1 times 5, so 1 and 5, both negative. That works. And here we can have x minus 1 minus 1, and here we also have x minus 1, x minus 5. Okay, so that replaces our denominator. I just wrote it that way so that I didn't have to rewrite the whole thing. So what is our common denominator? Our common denominator needs to have an x minus 1 and an x minus 5. But this one had an x minus 1 squared, so they all have to have an x minus 1 squared. So this one is missing another x minus 1. And again, you need brackets on top if you didn't have them. This one's missing an x minus 5. And this one's missing another x minus 1. Again, now that our denominators are the same and we have an equal sign, we can multiply everything by the common denominator, leaving us with just the numerator, x plus 8, x minus 1, minus 8, x minus 5, equals x minus 8, x minus 1. So we can just multiply this out. We get x squared plus 7x minus 8 minus 8x plus 40 equals x squared minus 9x plus 8. So let's get everything to one side because we've got squares. Oh, but wait, these squares actually disappear when we subtract them. They're 0. So we've got positive 7x minus 8x. So 7 minus 8 is negative 1, but then we're going to add the 9x. So that is now 8x. And let's just write everything else. So the plus 40, the minus 8 equals the 8. So then we've got 8x, and then we've got 40 minus 8, which is 32. But then we're going to subtract that from both sides, so we have 8 minus 32 on this side, which is negative 24. 8x equals negative 24, leaving us with x equals negative 3. Now we have to make sure that there's no problems with the domain, and that is fine because everything works there. So our solution set is negative 3. Let's take a look at this last one here. Here we've got x plus 5, here we've got x minus 5. Now this can become x plus 5, x minus 5. So now we need a common denominator of x plus 5, x minus 5. This one's missing an x minus 5. This one's missing an x plus 5. And this one is complete. Again, we have an equal sign, so we can multiply everything by the denominator, leaving us with the numerator of 6x, x minus 5, minus 30, x plus 5, equals 6x squared plus 150. So let's solve that. We've got 6x squared minus 30x minus 30x minus 150 equals 6x squared plus 150. So if we subtract the 6x squared from both sides, now we're left with negative 60x minus 150 equals 150. Add 150, you get 300 equals negative 60x, and that gives us, when we divide both sides by negative 60, that gives us negative 5. However, if we plug that in, you always need to test your results, right? Because from here, the domain restriction tells us that x cannot be negative 5 or 5. Well, x can't be negative 5, and that's the only answer we received. So we need to reject it, and therefore there is no solution. So you just can say that there is no solution.